Ladies and gentlemen, welcome to day 12 of April's Daily LeetCode Challenge. Day 12's question is question 42, trapping rainwater. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So our goal here is to find the blue spots given a XY graph as such. And if we look into a chart like this, we can understand how we can find a blue spot like this in our minds, which is based on simple gravity, but how can we do it in code? So let's think about it. In order for us to get this spot right here, we would have to subtract its current height, which is 0, and its left max height, which is 1. So its left max height, the boundary on its left, is 1 minus itself, 0, equals 1. So we have one blue spot here. And let's do the same for this T right here. At this spot, we have a height of 1 and a left max of 2. So 2 minus itself, 1, would be 1. So we get one blue spot here. And let's continue to this middle part. It would be the left max, which is 2, minus itself, which is 0, which equals to 2. So that is how you basically calculate the blue squares. And if we switch over to the right side, we have this blue spot right here. We have a right max of 2 and itself, which is 1. 2 minus 1 equals 1. So that's how we get this blue spot right here. So the solution I have for you is a 2-pointer solution. We will have a left and right pointer at the 0 index and the last index, at the first and last index. And then we will move the left and right pointers until they meet at the tallest elevation. So if we look at example 1, we will have left index right here and right index right here, and we will move both indexes until they meet at the tallest elevation, which is this one right here. So we will keep a left max and a right max to help us calculate the water spots. And then we'll get into our algorithm right here. So if the left max is less than the right max, we will move the right max. Oh, we will move the left max, sorry. And if the right max is less than the left max, we will move the right max to the right and to the left, which is +1, and this one is -1. And every time before we move our left and right pointers, we will calculate the water spots, if any. And the runtime is O of n because we have to iterate through every x axis on the graph. So we would have to hit every x axis on this graph. So the runtime would have to be O of n. And then the space is just O of 1. We don't keep any extra data structures to help us calculate this answer. So we will start the coding. Left and right pointers 0 and 0, left max, right max. We will initialize it to the height of our left pointer and the height of our right pointer. And our right pointer is not 0, it is, the index is actually going to be the last index, so the length of height minus 1. Okay, we have the left and right pointers, and we have the max pointers. Now we need to move the left and right pointers until they meet at the tallest elevation. So while left is less than right, we will keep iterating. So if left max is less than right max, left plus equal 1, else right minus equal 1. Every time before we move our left and right pointers, we will calculate the water spots, if any. So our answer is 0, and before we move the pointers, we will calculate the spots. So our answer is plus equal the left max minus the current height of left. Same with right. Our answer is right max minus the current height of right. Oh, and we also have to update our left max and our right max. So left max equals max of left max and the current height of left. So we're finding the max of our old left max and the current left height. Same here. And then at the end, we'll just return answer. That is the solution. Submit. Thank you for watching. See you in the next one. Peace out.